Hi, hello, welcome to Dr. Zahir Math. In this video, we are diving into section 15.6 triple integrals, which is multiple integrals. Okay, we will explore that, what they are, why we need them, and how they help us solve real world problems in Calculus 3. Right, let's get started and make it easy to understand. First of all, you should know we use multiple integrals to calculate volumes, masses, and probabilities over regions. They extended single integrals into higher dimensions, making them powerful tools in engineering, physics, and beyond, right? So this is what we are going to do it. So in this case, we are going to do just triple integrals only. Let's go to the first question. Evaluate the triple integral xyz square dv. dv is called as volume integral. dv is called as what? Volume integral. Volume integral, it can be, volume integral can be volume integral can be, because it is a triple integral, so triple integral dx dy dz, or it can be triple integral dy dx dz, or it can be dz dy dx. So any one order according to the given questions you can follow. If it is not given, you can take any of one of your choice, right? Take any one of your choice. So evaluate the triple integral, right? This integral is given where b is the rectangular box given by b is equal to set of all xy. For all x and y, the limits for x is 0 to 1 and y is minus 1 to 2 and z is 0 to 3. So we are going to evaluate this integral. So triple integral, the question is x, y, z square, right? The question is what? X, y, z square. X, y, z square into dv, right? So what I'm going to do, I'm going to write this triple integral x, y, z square. This dv, I'm going to write it as dx, dy, dz. Up to your choice, keep in your mind. So if you put like this is your inner integral. First, you have to do this one. This is called middle integral, okay, right? Or the center integral, we can call. And this is the outer integral. It means this limits for x, and this is for y, and this is for z, okay, right? So what is the x limit given? X limits given 0 to 1, so we are going to put 0 to 1, and the y limit given is minus 1 to 2, right? And z limit is given 0 to 3, right? So we are going to integrate this one. Let's go for the integration. Okay, right. So first of all, you make sure it is in plus or minus, or it is in product, or just in general I can say the question which is given is in product or not. Products. Yes, it is in product, right? Yes. So can we move here and there? Yes, we can move here and there. So let me start the integration. So integral 0 to 3, this is for dz, and integral minus 1 to 2, and integral 0 to 1, right? And dx, dy, and dz, okay? So let me take the z square here, and I will take the y here, then I will take x here, right? So this equals, first you start from the inner integral, x square divided by 2, the limits is 0 to 1, and this is y square divided by 2, limits is minus 1 to 2, and this is z cube divided by 3, the limits is 0 to 3, right? So this equals, let me take this 3 out, 2 out, and 2 this out. So 1 divided by 3 multiply by 2. So all these things I am taking out. So then z cube to the 0 to 3, then y square, which is minus 1 to 2, and x square, it is 0 to 1. So let me do here 1 divided by 3 times 2 is 6, 6 times 2 is 12. Let me open upper limit minus lower limit. When I put the upper limit, it is 3 cube, and the lower limit is 0. But here, when I put the upper limit, it is 2 square minus 1 the whole square. Carefully do it. Then when I put the upper limit here, 1 square, and the lower limit is 0. So carefully do this part, very, very important. So it is 1 over 12, bracket open. 3 3s are 9, 9 3s are how much? Which is 27. 27 multiply by 2 square is 4, and this is minus 1, because minus 1 the whole square is what? Which is plus 1, okay? This is going to become plus 1. So 4 minus 1 is going to become what? 3, right? and then this multiply by 1. So 27 multiply by 3 multiply by 1. So this is equal to, you put in the calculator or whatever you want. So this is nothing but your 27 multiply by 3, right? 27 multiply by 3, okay, divided by 12 gives 27 by 4, which is equal to 6.75. 27 by 4, which is equal to 6.75. Okay, so it's very clear. So let's go to the next question. Now the first thing is, this is also evaluate the triple integral. Okay, right. Look at the question. It is in product or not product? It is in product. No, there is a plus minus is there. So it is not in product. So it is not in product. It is not in product. So can we move here and there? No, we cannot move here and there. Keep in your mind. So let's do the integration first. Integral 0 to 2. Now the inner integral goes with respect to x. I'm going to do the integration with respect to x. So this is 0 to z square. Let me do the integration with respect to x. It is 2x square divided by 2. Slowly I'm doing. This integration goes with respect to what? Which is y, and it's a constant. So it is yx 0 to y minus z. After you finish the integration, just make sure you are going to put the limits for x, because you have done the integration with respect to what? X. Keep in your mind. So integral 0 to 2, integral 0 to z square. This 2 gets cancelled. Let me write one more time. X square minus yx 0 to y minus z. We are going to put the limits for what? X and x. So this is equal to integral 0 to 2. I just forgot this differential coefficients. Dy dz and dy dz. Okay, right. So integral 0 to 2, integral 0 to z square. Upper limit substitution y minus z the whole square minus y into y minus z. Okay. Minus lower limit substitution, here 0 and here it is 0. Into dy into dz. Okay. So let me work out this y minus z the whole square. Y minus z the whole square is nothing but, which is a minus b the whole square. What is a minus b whole square? A square minus 2ab plus b square. Right. So what is in the place of a? Y. What is in the place of b? Which is z. So which is y square minus 2yz plus z square. Right. Yes. Now what I'm going to do? I'm going to put this one inside. So which is integral 0 to 2, integral 0 to z square, bracket open. So this part is going to become y square minus 2yz plus z square. After that, I'll multiply this one, which is minus y square. I multiply this one, minus of minus, which is plus yz, and then close the brackets, dy and then dz. Okay, right. So now we are going to simplify this one. Integral 0 to 2, integral 0 to z square, bracket open. Y square gets cancelled. Minus 2yz and plus yz. Okay. So you will get minus yz and then plus this z square. This one, right? And this is dy dz. You are going to integrate now with respect to y. So integral 0 to 2, integral 0 to z square should not be written, because we are going to start the integration. So it is minus y square divided by 2z plus, and then z square is a constant, which is z square y, integral 0 to z square into dz. After the integration is over, just make sure we are going to substitute the limits for what? Y. That is very, very important. So when I put the lower limit, it will be 0. So I'm going to put only the upper limit. Integral 0 to 2, right? Minus bracket open, z square for y. After that, there is a square. So square and then z divided by 2. And then plus z square into y will be what? Z square into dz. Okay, right. So this equals integral 0 to 2, bracket open. This is z to the power of 4 and this is 1. So it's going to become what? Minus z to the power of 5 divided by 2. Right. And then plus this one is z to the power of 4 dz. So now we are going to integrate with respect to what? Z. Integral 0 to 2, let me write because it's not clear, so it goes up. Minus z power 5 by 2, right? Z power 5 by 2. Yes, z power 5 by 2. And then plus z power 4. And then plus z power 4 into dz. Let me check once again. Right. So this equals, integration starts, minus z power 6 by 6, which is going to become 12. and then this is z power 5 divided by what? 5, and the limits is 0 to 2. So this equals upper limit substitution 2 power 6 divided by 12, and then plus 2 power 5 divided by 5. Lower limit substitution 0 and 0. We are going to put this in the calculator. Just a minute. Okay, right, there is a minus fraction mode, and there is a minus bracket open, 2 to the power of 6, okay, divided by, which is 12, and then plus fraction mode again, 2 to the power of 5, okay, divided by 5, yes, which is going to become 16 over 15. So this equals 16 over 15 is your answer. Clear, all of you? Just an easy question, so easy to answer in final exams and the quizzes. Okay, right. So let's go for the next question. So here also triple integral. So the inner integral goes with respect to z, and the middle integral goes with respect to dx, and the outer integral goes with respect to y. Is it in product? Yes, it's in product. Can we move here and there? Yes, we can move. Right, let me start the solution. Okay, right. So let me start the solution. Integral 0 to 1 and integral 0 to 2, sorry, it is y to 2y, and integral 0 to x plus y, and 6 anywhere you can take, no problem. So let me take 6 as out. Now this is going with respect to z, so just keep z, there is no variable z. And here it goes with respect to x, so middle variable is x, and here it's coming y. Look here, first z, then x, then y. Okay, right. So keep in your mind, you can move here and there, no problem. Right, this equals in 6 integral 0 to 1. You should not integrate from left, you should start from here. Okay, yeah, right. So it is x, this will be dx, this will be dy. Okay, and this will be dy, and this will be dx. Right, now the integration goes with respect to z. What is the integration of dz? Which is z, so which is 0 to x plus y. Right, if I do the upper limit substitution, it is x plus y, minus lower limit substitution is what? 0. Now look here, there is a function related to x and there is a function related to x. So you should not keep this variable outside of dx. So let me go bring it here, and then dx will be out. So what happens now? 6 times integral 0 to 1 y dy, right? And then integral y to 2y, x will be there, x plus y will be there, and times what? Which is dx. Why you didn't take this y? Because this is completely free from plus. So that's why I'm keeping this side. So 6 times integral 0 to 1 y dy, integral y to 2y, I just multiply this one, which is x square, plus I multiply this one, which is going to become what? xy into dx. So this equals 6 times integral 0 to 1 y dy, and the integration goes now. The integral of x square with respect to x is x cube divided by 3, and integral of x is, which is x square divided by 2y, and the limits is y to 2y into dx. So this equals 6 times integral 0 to 1 y dy, bracket open, upper limit substitution, which is 2y the whole cube divided by 3, plus 2y the whole square divided by 2 times y upper limit, minus lower limit substitution, y cube divided by 3 plus y to the power of, this is 3, okay, this is 3, okay, this is 3, and this is y square by 2, okay, lower limit, because y square, we are putting x is equal to y, and then times y, right? So into this dx is finished, right? I think the integration is finished, so I should remove this dx. Yes. So 6 times integral 0 to 1. So 6 times integral 0 to 1 y dy, right? Now slowly you simplify this one so that you will not make any careless mistakes, which is 2 cube, which is 8y cube divided by 3, plus this one is 2y cube divided by 2, and this minus I'll take inside, minus y cube divided by 3, okay, right, and then minus y to the power of 3 divided by 2, okay, right. So all these things, and there is a y outside also, make sure, okay, right. So let's start this one. So this is 6 times 0 to 1 y dy. Let me simplify these expressions. there is all y cube, y cube, y cube, y cube. So what you should do, take your calculator, 8 by 3 plus 2 by 2 minus 1 by 3 minus 1 by 2. Actually this is 8 by 3 or 2 by 2 is 1 minus 1 by 3. Okay, minus 1 by 3 minus 1 by 2. Let me start here everything together. Okay, fraction mode 8 divided by 3 and then plus 1, then after that minus fraction mode 1 divided by 3, then after that minus fraction mode 1 divided by 2. So all together, which is 17 by 6. So this is all together 17 by 6 y cube. 17 by 6 y cube. Okay, right. So this equals, now I'll join with this, 6 times integral 0 to 1, 17 by 6 y cube, and this one which is going to become y power 4 into dy. 6 gets cancelled, so which is equal to 17 y power 5 divided by 5. So which is 0 to 1, which is 17 over 5. So I made a small mistakes. It is not 17 by 5. Let me check where is the mistake. Yes, I have done a mistake here. This is 2y square by 2, which is going to become 2 square is how much? Which is 4. 4y cube divided by 2 minus y cube by 3 minus y cube by 2. So this is 4 by 2, which is 4 by 2, which is going to become, it is plus 2, right? So let me check now, which is 8 by 3 plus 2. 8 by 3 plus 2, which is 23 by 6. It is not 17, which is 23 by 6. Okay. And this is also going to become 23 over 6. Okay, right. And then 6 gets cancelled. So you will get 23 here, right? And then here also you will get 23 divided by 5. Luckily I found out the mistake. Yes, otherwise the whole video will be disturbed. Thank you. Right, alhamdulillah. Right, it is 23 divided by 5. So this is going to become your final answer. Okay, right. It is not 17, it is 23 divided by 5. So let me tell you again. This is 2y squared, 2y the whole square. So which is 2 square is how much? Which is 4. And then this is y square multiplied by y is y power 3. Okay, so keep in your mind. Let's go to the next question. Integral 0 to integral 1 to 2, integral 0 to 2z, 0 to ln x, x e power minus y, dy, dx, dz. Before going to this, I want to say a few things about some rules. What is that rule? The rule which I am going to tell is, which you studied in 002. E power ln a is equal to a. What's the meaning of that? E power ln 2 is equal to 2. You can check in the calculator also. Check in the calculator please, you can check. E power ln 2 is 2, right? And also I need to tell you one more rule from the logarithm, which is power rule. So power rule is what? Suppose you have ln 2 to the power of 3, you can write it as 3 ln 2. Okay, so keep in your mind. So in this way, suppose you have a situation, for example, so let me use the same power rule for the expressions over here. Suppose you have, for example, ln, okay, x, ln x, for example, I'm taking this as e power. So if you have e power ln x, it will be x. But suppose if you have e power minus ln x, how can you write? You cannot write it as minus x. So what you need to do, using this power rule, look here, this is on the top. So you can take this one to the power. So this minus I'm taking to the power. So which is e power ln x to the power of minus 1. So this is going to become what? E power ln 1 by x, or just keep it as x power n. So what happens now? This is of the model e power ln a, right? What is your a? Your a is x power minus 1. So your answer is x power minus 1, which is going to become what? 1 by x, right? So suppose I give another example. Suppose you have a situation e power minus ln 3. So you can write as what? E power ln 3 power minus 1. What is the answer? 3 power minus 1, which is going to become what? 1 by 3. Now it's more clear. When I give numbers, you'll be very clear. So this is the example, just keep it in your mind. This situation will come inside this problem. If you use this, your integration will be very simple. Otherwise, you have to use lot of steps or you have to use substitution method. Right. Let's start the solution. Right. So first of all, you just make sure this is his product or not. Inner integral goes with respect to y, right? And the middle integral goes with respect to x. And the outer integral goes with respect to what? Z. So it is in product. Yes, it is in product. So can we move here and there? Yes, we can move. Right. So what I'm going to do, integral 1 to 2. And this is for z. There is no z here. Keep here. There is no z. Keep your eyes on there. So integral 0 to 2 is z. And this middle integral goes with respect to what? X. So let me pull this x over here. So it is x and dx. Then this I pull this dz here. And then integral 0 to ln x, I just make here e power minus y dy. So everything I'm just moving according to that. So integral 1 to 2 and then dz. Integral 0 to 2 is at x dx. Okay, right. Now the integration of e power minus y is going to become what? E power minus y divided by what? Minus 1. And the limits is 0 to ln x. Okay. Let me take this minus out. So this is equal to what happens? 1 divided by minus 1. I will take it out. So integral 1 to 2, right? Into dz, and integral 0 to 2 is at x dx. Okay, right. Now upper limit substitution e power minus ln x. We are going to substitute for y. Minus lower limit substitution e power minus 0. Right. So this equals 1 by minus 1 is minus 1. Integral 1 to 2 dz. And integral 0 to 2 is at x dx. Okay. Look carefully here. E power minus 0 or e power 0 is plus 1. What about this one? E power minus ln x. So this can be written as e power plus ln. This minus I'm taking to the power using power rule, which is x power minus 1. So in this way, my answer is e power ln a, which is equal to a. So what is your a? A is x power minus 1. So x power minus 1 is nothing but what? 1 by x. So in this place, I'm going to put 1 over x, which is this one. Correct? Yes, 1 over x. Right. Now this is also function of x and this is also function of x. Look here. And definitely I should not keep variables after dx. So I should took all these things, okay, to inside. So keep in your mind. So this equals, right, minus 1, integral 1 to 2 dz, and integral 0 to 2 is at x times 1 by x minus 1 times dx. So this is going to become minus 1 integral 1 to 2 dz, and this you multiply here, integral 0 to 2 is z, right? Integral 0 to 2 is z. Okay, 2 is z. This is 2, but half cut, 2 is z. So this is x multiplied by 1 by x, which is x gets cancelled, it's 1. So 1 minus this is x. Okay, so close this one and then write dx. So I need this one. So minus 1 integral 1 to 2 dz. So now I'm going to integrate this one. When I integrate, I will get what? X, right? And then minus x square divided by 2, right? So the limits are for here, it's 0 to 2 is z. So this equals minus 1, right? Integral 1 to 2 dz. I'm going to put upper limit minus lower limit. Lower limit is 0. So which is 2 is z minus 2 is z the whole square divided by 2. Lower limit of course 0. So this equals integral minus 1 and then 1 to 2. See here, this is also in z. This is also z. So I shouldn't keep dz before the variables. It should be out. So this will be 2z minus 4z square divided by 2. Right? Yes. Into dz. So this equals minus 1 integral 1 to 2. Okay. 2 is z minus this 2 and this 2 gets cancelled. So you'll get 2z square into dz. Now I'm going to integrate with respect to what? Z. So it will be 2z square divided by 2. Z and 2. This is 2. 2z square divided by 2. Okay. Minus this is 2z cube divided by 3. And the limit is 1 to 2. Okay. Right. So we are going to put upper limit minus lower limit. So 2 gets cancels. Okay. Right. Which is 2 square minus 2 by 3 2 cube. This is upper limit. Minus lower limit is 1 square, which is 1, minus 1 cube is also 1, which is 2 by 3. So upper minus lower. Okay, right. So let me simplify this answer. Just a minute. So if I simplify all these things in the calculator, I'm getting as minus 5 over 3. Okay, right. So it's going to become what? Minus of minus, which is going to become plus 5 over 3. So this is going to be your final answer. Okay. Right. So this finishes your module 4, which is multiple integral topics, as well as your calculus 3 is over. Alhamdulillah, we finished the calculus 3 course. Thank you for watching my channel. It is not just the video, but for joining me on this entire journey through calculus 3, right? I started this YouTube channel just 4 months ago because of you, my dear students, and it's been such a joy to share these lessons with you. Your support, encouragement, and dedication have meant the world to me. Please keep sharing the channel, stay curious, and never stop learning. I'm so proud of all of you and can't wait to see you reach even greater heights. See you in future semesters and future courses or whatever it is. What to say? Once again, thank you very much. Please keep sharing all these things with your upcoming juniors, with your brothers who are coming from Calculus 2 and all. See you soon on Dr. Zahir Math. Take care. Bye bye.